smart manufacturing is one of the things that's been in the news, and everybody's talking about smart manufacturing. There's articles and videos and whatnot. I'd like to tell you about my thoughts on that. I'm John Rinaldi from Real Time Automation. I do strategy, I do a lot of articles, I do a lot of videos, and this whole smart manufacturing is something that I have really been focusing on for the last few months. So what is smart manufacturing? Unfortunately, this term, it means nothing to some people. It means a lot of different things. It could mean predictive maintenance. It could mean some kind of advanced analytics. It could be analytics in your on site. It could be an analytics in the cloud. What is smart manufacturing? But I guess you really have to look at this in terms of the results. And anything that allows your processes to be better than they were before is really what is smart manufacturing. So you're trying to get data and operate more efficiently, more effectively than you have in the past. So it could be anything. One of some of the people I think that have really done a good job of talking about smart manufacturing and defining it is an organization, a trade organization actually called Sesame. And I don't remember what Sesame stands for, but they are a government-funded, Department of Energy, I think, funded organization that is trying to do smart manufacturing. So I have this is what Sesame defines as smart manufacturing. It starts, of course, with the manufacturing process. There's some sensing to create data. There's a contextualization, so you make that data useful. Analytics that operate on it, insights that get generated, applying models to it so that you could really compare it to other operations that you have, and then there's feedback into your control system. So Sesame has a real nice model of really what advanced smart manufacturing is, and they've kind of gone. They're trying to get it to the ultimate way to operate. For example, when you get a new printer at home or at work, you just download the driver, and now your computer knows how to talk to that printer. Well, they're trying to do the same thing for manufacturing. So if you have a ultrasonic sealer, if you have some new linear actuator, if you get a new machine, you get you buy a machine from a machine builder. That machine, that no matter what you have, that you'd be able to go to the cloud, grab an information model for that, and now all of your applications would know how to talk to that and get the data very easily. I mean, it's a big, big, big idea, and I applaud them from taking that on, but it just seems that it's pretty hard to do. But they're taking a good shot at it. Now, the big thing about what's really important for smart manufacturing, there's one thing that you have to have that to do smart manufacturing, and that what you have to have is the data. That means you have to be able to reach into the machine, and you have to be able to grab the data that you need. If you can't do that, none of that other stuff that's on that circular chart graph that they put together matters. So, and that's one of the things that I want to talk about today. And I've talked about the two basic ways that people are doing this now, the two most important, MQTT and OPC UA. Now I've done a video comparing these. This video, I won't talk about them as much. You can go look at that if you want. But generally, MQTT, the data is untyped. They have their own sort of profile that you could use to make a model for your machine or whatever, so that the receiver would know what they're receiving. OPC UA, of course, has done it to an nth degree. With OPC UA, you make some very sophisticated models. For example, here's a model I use in my OPC UA book for a oven. And it's and you have all of these different charts. The nice thing about this is that you can traipse through this, browse through this structure, find the data that you want, and then access it, tell the OPC UA server that has this data, hey, let's give me that data, and I want this particular variable every 50 milliseconds. I want this other variable every 3 seconds, and it'll publish the data to you on the schedule that you want. So that's very nice. Those two things is what we need to solve the data collection problem. But of course, as you know, everything on the factory floor is not OPC UA or MQTT. Well, that's when RTA comes in. RTA provides the interface from the standard unstructured data that you have on the factory floor. This stuff is somewhat proprietary. Some of it's open, some of it's semi-proprietary. We provide the links to get from the factory floor into that data. And you'll see some links down below where we have ways of getting OPC UA data, getting data into OPC UA, getting data into MQTT. If you have an old PLC, a PLC 5, you have some of the old SLCs, whatever you have. If you have Allen Bradley, if you have Siemens, we have ways of getting that data into a place where you can then do smart manufacturing. Because as I said, if you don't have the data, there's nothing you can do. So if you're trying to do some smart manufacturing, we'd like to help you. We have the capabilities of helping you solve your problem. So give one of our application engineers a call. They'll be able to discuss your problem, how we could provide a quick, easy, simplified solution to do this. And then once you do that, you'll be able to use that data and improve your manufacturing process and do some smart manufacturing without having to do all of these full-blown kinds of systems that Sesame is talking about right now. So it's much more simple, and that's the business that we're in, is helping you get things done and get them done very simply and easily. So I'm John Rinaldi. Feel free to give me a call or one of our application engineers a call anytime you need some help trying to collect data from the factory floor. Thank you.